Well, happy Thursday. Today we're going to be talking about dividing with complex numbers, so essentially looking at complex fractions. All right, so what makes it complex, or what are the rules for these? So first off, we are not allowed to have imaginary or complex numbers to be in the denominator. That is just not allowed. All right, so we're going to figure out how to get rid of them if we have one. So here in green you can see an example. 1 over a plus bi, just a generic complex denominator. All right, so to do it, what we're going to do is we're going to multiply what's called the complex conjugate. All right, and that complex conjugate essentially is the same thing as the complex number, except the middle term has had its plus and minus signs switched. All right, and then anytime you are going to do something to a problem, you have to keep things fair. So you're not allowed to just multiply a denominator by something unless you also multiply the numerator by the same thing. Essentially, since those things would multiply or divide out to equal 1, we're allowed to multiply anything by 1. If you multiply something by 1, it hasn't changed. So that's why we're allowed to do this. All right, and here's my little reminder as to why this is helpful. All right, if I take something just without the imaginary number part, just an a plus b and an a minus b, which is what we're going to get in every problem today. What happens is when you do FOIL, the two middle terms will cancel each other out, leaving just a squared minus b squared. Now again, that only happens when these two things are exact copies, except one has a positive middle term and one has a minus or negative middle term. It's the only way it happens. All right, so let's practice. All right, so again, the problem with this one is we're not allowed to have that I number in the bottom. So to get rid of it, what we're going to do is we're going to multiply by the complex conjugate. It means keep the first number the same and switch the plus and minus sign on the second number. We have to multiply the numerator and the denominator by that same thing. All right, so in my numerator, I'm going to multiply it by 5. And anytime you're timesing one thing times two things, it's like a distributive property problem. So my numerator is now going to be negative 30 minus 20i. All right, now in my denominator, we end up with what I showed you a minute ago. We have the exact same thing except for the middle term has been switched from plus to minus. When that happens, we end up with a squared minus b squared. In this case, it would be 4i. And that's what we get, the a squared minus the b squared number. So my a squared, negative 6, that makes 36. And then when I square that 4i, I'm going to get, whoops, not equals, silly. I'm going to get minus 16i squared. 4 squared is 16, and I squared is I squared. All right. Now, if you remember from yesterday, we talked about how an I squared is actually equal to a negative 1. So this numerator hasn't changed. But the denominator, this is 36 minus 16 times negative 1. When you times something by negative 1, negative 16 times negative 1, I'm going to end up with positive 16. That means I now have, and it's a little messy, negative 30 minus 20i over 36 plus 16 is 52. So I've done all the cleanup. The denominator no longer has the I, so that's good. I just need to make sure my fractions are reduced. And I see only even numbers here, so I'm going to divide everything in the problem by 2. I get negative 15 minus 10i over 26. Now there is nothing that goes into 26, 10, and 15, so I am finished. These are not pretty. They're not impossible to do either, but they're definitely not pretty, and there's a lot of places to make mistakes. All right, so you just got to be careful. All right, let's try another one. This one looks a little harder, but it's about the same exact thing. All right, so the first thing we want to do is we want to go ahead and multiply by the complex conjugate, which would be 2 minus 9i. Well, that's an ugly 9. 2 minus 9i, and the same thing for the numerator. All right, so both cases we have some FOIL going on. All right, so I'm going to go ahead and do FOIL for my numerator. My first times first would be the 1 times 2. My outsides would be the 1 times negative 9i. Man, I keep curling my 9s because I'm used to curling the i's. And then insides would be negative 3i times 2. And then last, negative 3i times negative 9i, which would make 27i squared. All right, denominator, we have that complex conjugate, the 2 plus 9i, the 2 minus 9i. I'm just going to get 2 squared, which is 4, and then minus the 9i squared, which would be 81i squared. All right, now in both cases, I can go ahead and replace the I squareds with negative 1s. So I'm going to go ahead and do that in both the numerator and denominator. Replace that I squared with a negative 1 in both places. Now let's clean things up. All right, numerator, I've got some like terms, these two I terms, and then I've also got constant terms. All right, constant terms come first with imaginary numbers. So I've got 2, and then back here in the back, it's 27 times negative 1, which really makes negative 27. So I've got a positive 2 and a negative 27, which makes negative 25. Now the ones with i's in them, negative 9 and negative 6 makes negative 15. Now my denominator, 4 minus, well, negative 81 times negative 1 is positive 81. So it's really 4 plus 81, which is 85. And I see that all of these can be divided by 5. It's going to get me a negative 5 minus 3i, and then denominator 85 divided by 5 is 17. And that is now reduced. No more I in the bottom. All right, I know these are a little slow, and there's a lot of time or a lot of places to make mistakes. So you only have 4 problems, I think, today. But again, it's a lot of places to make errors. So if you need any help, you know how to get a hold of me. Get me on the Zoom, or email me, or call me here in the classroom. Any of those will work. All right, good luck today.